Hello YouTube and welcome to the last video in the transformations unit. So in this video we'll be combining everything we've learned and just doing some questions with them. So here's a helpful image I found online, and it basically is an outline for everything what transformations do. So you can see here it discusses translations, either left or right, and stretches and compressions, as well as reflections. So credit to Maths.Sir for this graphic I found. So you guys can use this if you need, but let's move on. So before we actually solve any problems, there is a specific order you need to do when you want to apply transformations, because if you don't do it in this order, then things can get messy and you won't get the correct answer. So first of all, what you want to deal with is you want to deal with vertical stretches and reflections first. So that's your A value here. It's going to tell you whether you're reflecting, how far you're stretching up or down. Secondly, you're going to do horizontal stretches and reflections. It's your B value. It's going to tell you a lot of information on the horizontal stretch. And third is horizontal translations. It's your H value right here. So basically it tells you how far left or right you're going. And lastly, your vertical translation, which is your K, where you're going up or down, depending on what the value is. So without further ado, let's go on to some practice problems. So the first question states, identify the transformations on each function compared to its parent function. All right, so firstly, it's probably important just to note, whoops, too thick. Let's just identify the parent function. The parent function is y is equal to absolute value of x. And now we'll start by doing some transformations. So let's identify the vertical stretch for now. So what I'm seeing here is this is the vertical stretch. So it's, let's just write it down. Vertical stretch by a factor of 3. And if you're not familiar with this writing, you can watch a previous video which I described how to write your transformations. So basically, when you see your vertical stretch here, you just want to write it whatever this number is. So I said vertical stretch by a factor of 3. That applies for vertical stretches. So now let's move on to the horizontal stretch. Our horizontal stretch is going to be inside the x. So I'm looking at this part right here. So it's going to be a horizontal stretch, 1/2. So let's write that in. A horizontal stretch, and if you remember, we have to do 1 divided by this. So we have to do 1 divided by 1/2, and this should equal to 2. So remember, we're always going to write our horizontal stretch based on our 1/b value. So if you go over here, I have a thing here. So remember, whenever you're stating the horizontal stretch or you're graphing it, you always want to do 1 divided by your b value. That's going to state your horizontal stretch. Let's go back here. So we can write horizontal stretch by a factor of 2. Let's get rid of this here. So you always want to do 1 divided by your v value to figure out your horizontal stretch. So let's move on to translations now. So what I'm seeing here is this inside the x here is going to tell us how far left we're going. So because there's a plus here, that means we're going to go 2 units to the left. So we can say, remember, it's a horizontal translation because inside the x, horizontal translation 2 units left, because we're going 2 units to the left here. And lastly, for our vertical translation, we have a -4 here. That means we're going to go 4 units down. So we can say vertical translation 4 units down. And lastly, we have to check for any reflections. I'm not noticing any negative values here or in the inside and x or b value. So therefore, we don't have any reflections, so we can move on. So now let's move on to part B. So we have the function g of x equal to -2 times square root of x minus 1 plus 3. So let's start by identifying our parent function. So we have our base function, y is equal to the square root of x. That's our parent function. So now let's start by identifying some transformations. So I'm going to start with the vertical stretch and reflection. So what I'm noticing here is there is actually a negative sign here, and this signifies that we're dealing with reflection. So I'm going to write that in. So we're going to say a vertical stretch. So I'm going to first deal with this right here, vertical stretch by a factor of 2. And we're also going to be dealing with a vertical reflection here. So we're also going to say vertical reflection. So now that we've got our vertical stretch and reflection identified, let's move on to some translations. So I'm not seeing any b value here, so we can skip that. We can move straight to translation. So inside the x, we see an x minus 1. That means we're going right 1 unit. So we can say horizontal translation right 1 unit. And for our last transformation, I'm not seeing anything else except for this vertical translation. So we're going to say vertical translation 3 units up. And there we go. I think we've identified all the translations and transformations. So we go on to part C. So we're given the function h of x, and let's identify the parent function. So what I'm seeing here, it looks like it's a quadratic. So we're just going to say y is equal to x squared. Okay, so let's start by identifying the vertical stretch. So I'm noticing here there is nothing here, so that means we can treat that as a 1. But there is a negative sign here, so that means we're dealing with a vertical reflection. So we can just right off the bat say vertical reflection. And you can leave it like this, or you can say reflection across the x-axis to be more precise, but this is automatically fine. That's saying the same thing. So let's next move on to whatever's inside here. So it might be you might be tempted to say that there is a horizontal reflection here. Well, you would be right, but before we actually state our transformations, we have to make this simplified. We have to include more brackets here. So what I'm going to do here is I'm going to simplify this down. So instead of becoming minus x plus 3, it's going to become, we're going to factor out the negative, and this is going to become x minus 3. So this is your proper notation. Before we state any transformations, you always want to convert your function into the normal transformed, how do you say it's outline. So yeah, so you always want to convert into something like that, because if we try to state the transformations, then we would be just saying that we're going left 3 units, but in reality, we're actually going right 3. So it's always important you factor out the negative here. So let's start by stating the horizontal reflection, because there's a horizontal reflection, so we can say horizontal reflection. And we're going to be basing our transformations on this because we have to make sure everything's in factored form. So we can also say it's going right 3 units. So we can say horizontal translation right 3 units. And lastly, for our vertical translation, that's our last transformation left. So we can say we're going vertical translation 2 units up. So basically, to solve problems like these, you always want to make sure you have everything in factored form in your normal transformations outline, and you always want to start with either you want to start with your vertical stretches and reflections, then go on to your horizontal stretches and reflections, and then lastly your translations. All right, so let's move on to the next question here. So we're given the function f of x, and we're asked to write the equation of g of x in terms of f of x and state the transformations applied. So before we do anything really quick, let's just take a look at the two functions and see what's going on here. So what I'm seeing here is g of x is a vertical reflection of the function f of x because it's being reflected across the x-axis. So we've got one transformation right out of the way. And what else I'm seeing here is there's some sort of stretch being applied to g of x because it doesn't really have the shape of f of x, because f of x is kind of wide over here and g of x it's really pretty narrow here. So there's definitely some kind of stretches going on. And also there's, I could see there's some translations because this point does not match up with that point there. So we're dealing with a lot of transformations here. So let's take everything step by step. So there's two sort of ways you can approach this. You can either go down the vertical stretch route or the horizontal stretch route. The way I like to do it is doing based on vertical stretches. So what we're going to do here is, to do this method, we're going to basically see an identifiable point here. So it's usually good to go with the main identifiable point. In this case, it's going to be the vertex. And what we're going to do is we're going to count out a set value of x values, a set number of x. So let's say I wanted to pick the change in x to be 2. I could do 2 to the right. Or I could go 4 to the right. It doesn't matter. All you have to do is pick out a set number of x to go out. So I'm going to go just 2, just keep it simple. So 2 out. And the next step is you're going to count out how far you went up. So to the next point. So I'm seeing here is this is at 1, this is at 3. So it seems like I went 2 up. Okay, so we got that down. Now we do the same exact steps to the other function. So what we're going to do is we're going to go 2 out, and then we're going to count up how many times we go down, in this case, to meet the next point. So we have to count down. So we start at 2 and we end up at 6. That means we're going 4 down. So immediately, I'm noticing, since we kept these x the same, but the y's are changing. So in this case, it was 2 here, but now it's 4 here. And what that means is we're dealing with a vertical stretch. In this case, 2 times what is equal to 4, but there's just 2. So we're dealing with a vertical stretch by a factor of 2. So we can immediately write that down. So we can say, let me get a different color here. So we can say vertical stretch by a factor of 2. Because all we're doing, we kept the change in x the same, but we notice we're going up by twice the amount in this function, because in this function we only went up by 2, but here we're going up by 4, so we have to multiply all our y values by 2. So we're dealing with the vertical stretch by a factor of 2. So and we're also dealing with a vertical reflection, so we can say a vertical reflection. Okay. So before we do anything, let's just graph the transformations now. So now at this point, maybe pick a different color here. Say we want green. So now we're reflecting everything, and we're multiplying all our y values by 2. So this point is at 1, 2. It's now going to 2, 1. Sorry, it's not going to be at to negative 1. So right there. And since we're multiplying all our y values by 2, it's going to be down here actually. So you can get rid of this. So next, let's move on to some other points. The point, let's say we want to check the point for 3. So the point for 3, all we're going to do is we're going to flip this y value 3 to negative, so it's going to be a 4, negative 3. But since we're doing a vertical stretch, we're going to multiply the negative 3 by 2, so we're going to be at negative 6 right here. So we can get rid of this right there. And let's move on to one more point. Let's pick one from the left side here. So we're going to go with, let's just pick the point 0, 3. We're going to flip the y value so this number becomes negative. So we're going to do 0, negative 3. But since we're multiplying all our y values by 2, it's going to be at negative 6 right there. So there we go. There is the function applied with a vertical reflection and stretch. But we're still not done here. It seems like there's some transformations that are still left for us to go from this function all the way over to this function over here. So I think all we're left with here is translations, because we got the stretches dealt with. So now all we have to do is count the change in x here. So we have to go to each. We have to match up each point to here. So we're going to say we're going. What is that? 4 units, right? And are we going anything down? It doesn't seem like we have to go down at all, so we can just say it's a horizontal translation. Horizontal translation 4 units right. And there we go. I think we've answered part of the question. We've stated the transformations applied, but now we actually have to write the equation of g of x in terms of f of x, which shouldn't be too hard. I mean, we've dealt with some of this stuff before, so all we have to do is, let's just pick out g of x. We can say g of x is equal to, we have to apply these transformations to the function f of x. So it's going to be negative 2, since we're doing the vertical stretch and reflection, times f of x plus 4. Whoops, sorry, x minus 4, because we're going 4 right. X minus 4. And there we go. That answers the question. Hopefully that makes sense. And let's move on to the next one. So this next question asks, given the function h of x, sketch the graph of g of x equal to whatever this is. Okay, so let's start by identifying the transformations here. So it seems like we're going vertical reflection by I'm seeing like this. We can write vertical reflection. And there's also a vertical stretch here. So we can write vertical stretch. And what else I'm seeing here is there's a horizontal reflection. So we can write horizontal reflection. And there's also a horizontal stretch. Oops. And remember, with horizontal stretches, you have to divide this number by 1 divided this number. So you have to say a horizontal stretch by a factor of 1 over this value, so it's going to be 1 over 2. Okay, perfect. So if you remember from the order of transformations, we always deal with our vertical reflection and stretches first. So let's take this problem step by step, and let's start with the vertical reflection and translation. So all we're going to do is we're going to reflect all our values, so the point 0, 0 stays the same, but the point 2, 2 now gets reflected down to 2, negative 2. So the point 4, 4 stays the same because you can't really reflect 0. The point 6, negative 2 goes to now 6, 2, because the negative 2 switches to a positive. This stays the same. And the point 10, 2 goes down to 10, negative 2, and this stays the same. So this is the reflected function right here. So all we did was reflect across the x-axis, and now we have to apply our vertical stretch. So what we're going to do here is we're going to multiply all our y values by 3. So minus 2 times 3 is going to go down to negative 6. 0 times 3 is still 0. And this is still 0 as well. And 6, 2 is going to go to 6, 6, because we're multiplying our y value by 3. This stays the same. Same thing with this, goes all the way down here. And this stays the same. So we're left with this function right here. It's a pretty big function, connecting all the dots. And that's our vertical reflection and stretch applied. So now all we have to do is apply our horizontal stretch and reflection. So I'm going to pick a darker color here so you guys can see it better. So actually probably let's do green. So it looks like we're dealing with the reflection as well. So we're going to reflect across the y-axis. So this point can't really be reflected because it's right in the origin, so we're going to do there. But this point right here, 2, 6, that's going to be a negative 2, 6 because we're going to reflect all the x values. And so now we're done with this point. Let's do point 4, 0. It's going to be a negative 4, 0. The point 6, 6 is going to be a negative 6, 6 right there. We're just reflecting all our x values. The point 8, 0 is now going to be at negative 8, 0. And the point 10, negative 6 is going to be at negative 10, negative 6 over here. And lastly, 12, 0 is going to be at negative 12, 0. So this is our horizontal reflection over here. Right there. And now that we got the horizontal reflection done, let's just check these off. Let's move on to the horizontal stretch. So notice how we're dealing with a horizontal stretch by a factor of 1 over 2. We're just going to multiply all of these x values by a factor of 1 over 2. In other words, we're just going to divide them by 2. So let's pick a different color here. Let's say I want to do violet. Sure. So we're going to work our way from outwards to inwards. We're going to do negative 12 divided by 2. That's going to be negative 6. Let's do negative 10, negative 6. That's going to be to negative 5, negative 6. That's going to be right here. And the point 8, negative 8, 0 is going to be to negative 4, 0. The point 6, the point negative 6, 6 is going to be to the points negative 3, 6. And the point from negative 4, 0 is going to be to negative 2, 0. And the point negative 2, negative 6 is going to be at negative 1, negative 6. So we are left with a squished down version of our function. It's going to be like this. There we go. And the point 0, 0, I mean, that stays the same. And we're left with that. Okay, perfect. So now all we have to do is do a translation all left 1 unit because of this. So I'm going to use our red color now. So all we have to do is shift everything left 1 unit. So we're going to do It's going to go from -6 to -7. This is going to go from here to here. This is going to go from here to here. Just translating everything left 1 unit. So this is going to go from here to here. This is going to go from there. And this is going to go right there. And also this translates as well. So we're left with our final function of this right here. It might be hard to see because of all the other lines I drew. Oops, that doesn't connect. Make sure all the lines connect. Don't want to do that. And there we go. It's our red one, so we can say g of x. Okay, hopefully that makes sense. And our g of x function is obviously the red one here. That's how you apply and combine all these things. I know it might be a lot of steps, but that's just how it is. Hopefully that video made sense, and that concludes the transformations unit.